We're going to solve some of the problems that were extension for the mock exam. First of all, there is a continuous compounding problem. Remember, when you have continuous compounding, you have the exponential e, and for here you have the future value equals the present value times e to the e, and then in the exponent you're going to have the interest rate and the time in years. So in this case we have 31,564, which is the initial value. You're going to put that into PV. After 9 months they had 35,403. And then the R value is the unknown interest rate, so you just leave R. And the T value would be the time in years. So since it's 9 months, 9 months is 3/4 of a year, right? 0.75. So we're going to use 0.75 for the time. Okay. And then we're basically going to do algebra until we isolate the R. When you do that, you're going to get to the point where we need to use logs. Okay, but let's start with the easy part. First, we need to get rid of 31,564. We're going to divide both sides by 31,564. And so on the left side, we're going to end up with 35,403 divided by 31,564. And that is equal to e to the r times 0.75. Let's see what that equals to here. 35,403 divided by 31,564. Okay, it's 1.122. 1.122 equals e to the 0.75 r. Now, remember the snail? E to the 0.75 r, we're going to rewrite it so that the number is on the right side. And then we're going to do the snail, which is we're going to take the head. Okay, so it'll be log base e of 1.122 is equal to 0.75 r. And remember that log base e is the same thing as natural log. So we can find the natural log of 1, or actually we just have it here, so we'll just copy this number here. And our answer is 0.115 on the left, and on the right side we have 0.75 r. We can divide the 0.115 by 0.75, and that gives us r is equal to 0.153, and our answer for the interest rate is 15.3%. Okay. Next problem. Solve for an exact solution of x using log base 10 or natural log in your solutions expression. Okay. First of all, we recognize that this here is related to 5 to the x because 25 to the x is the same thing as 5 squared to the x, which can also be written as 5 to the x squared. Okay, and keep the coefficient of 3 there. Once we have it written like this, we are going to make it a little bit easier to factor by taking our 5 to the x's and replacing them with t's. Then we'll have 3t squared minus, minus t, and then we'll factor. Okay, And now we know that there's two ways of making that expression 0. One of the ways is t can be 0, and the other way is 3 minus t is equal to 0. And so t equals 0 is the same thing as 5 to the x equals 0, because we can substitute back in this expression there. And 3 minus t equals 0 is the same thing as 3 minus 5 to the x equals 0. 5 to the x equals 0 has no solution, because no matter what you put in x, you can never make an exponent equal to 0. It's the asymptote, so it can never equal that. So there's no solution here. 3 minus 5 to the x equals 0. If we subtract 5 to the x from both sides, we end up with that. And then we can find a solution to this. The way we find it, we're going to put the number on the right, and then we're going to do the snail. So, log base 5 of 3 equals x. So if we want to find the value for x, we're going to do log base 5 of 3. We can do that by using the property log base 10 of 3 divided by log base 5, divided by log of 5 equals x. Okay? So that's my exact answer. If I actually went to the calculator and did this, if I did, log of 3 divided by log of 5, it's no longer an exact solution. Okay? So we don't want to do that. We just stop there. Next one. Here we have some exponential values with a base of e, and it wants us to find a solution for x. So we need to isolate x. First thing you're going to do is you're going to try to get rid of your negative exponents. So the way we do that is we're going to multiply both sides by e to the x. If we do that, then e to the x times e to the negative x gives us e to the 0, which is going to be 1, right? So e to the x squared minus 12 e to the negative x times e to the x equals 4 e to the x. And look here, if I multiply e to the negative x times e to the x, I add the exponents, I get e to the 0, which is 1, so this middle term becomes negative 12. Okay, and then I'm going to subtract everything to the left side so that I have 0 on the right side so that I can factor. So I'm going to have e to the x squared minus 4e to the x minus 12 equals 0. Then I'm going to substitute my e to the x's for t, and then I'll end up with t squared minus 4t minus 12 equals 0. Then I factor it. It's going to be t minus 6, t plus 2. So there's two solutions that make this 0. One is t minus 6 equals 0. The other is t plus 2 equals 0. I'm going to substitute back in e to the x here, so it's e to the x minus 6 equals 0. E to the x plus 2 equals 0. This one would simplify into e to the x equals negative 2, which is never going to happen because exponential values, positive exponential values, cannot ever be negative. So, no solution here. And this one, e to the x equals positive 6, I can rewrite this using the snail. Log base e of 6 is equal to x. Okay, so basically x is equal to natural log of 6, and that is an exact expression, and I don't want to put it in the calculator because it asks for an exact expression, but if I wanted to find a decimal representation, I could do that, and the decimal representation would be about 1.79. Okay, alright, last one. Without using a calculator to simplify this expression, we're going to use the log rules for that. Okay, so if you have e to an exponent, you can group the exponents. So I could write this as e to the negative 4 to the natural log of 2, or I could write it as e to the natural log of 2 to the negative 4th. Okay, if I rewrite it in this way, it's convenient because e to the natural log of 2 is 2. Remember that e to the x is the inverse function of natural log. So if I put them in cascade like that, I get the original number. So then I end up with that. And then I'm going to have 1 over 2 to the 4th, which is 1 over 16, which is my answer.